Hi there, this is Robert Hodges. We'll be starting the meetup in just a few minutes. Looks like at least one person's on. Welcome, everybody.
Hello, Robert. It's Alexei.
Hi, Alexei.
Hello.
All right. Welcome to the fun. So I've got actually. Do you want to check real quickly that we can share your screen? Okay.
Oh, sure. Let's check that.
Yeah.
I will try it right now.
Yeah. Just a second. I'm sharing, so I'll need to let me unshare. All right. Go ahead and try and share. Put my video up here. That's cool. You made it. Thank you so much. It looks, I see you and you look awesome. And there's a demo. That's even more awesome.
Cool.
Looks great.
So the screen is showing all right?
Yeah, well, you know what I'm seeing is I'm looking at Keynote, but I'm actually not seeing a presentation screen. It may be on your other screen. If you have two windows,
No. It's just Keynote. I opened Keynote with a
just an editor view.
Actually, this one is correct one.
Oh, okay.
Do you see it? I can.
Yeah, I do. It looks great.
So this one.
Yeah. Oh, perfect. And yeah, it looks like.
Okay, good.
Yeah. Hey, so I'll probably run for about 30 minutes. I'm just doing a talk on your first ClickHouse data warehouse, which is sort of for people who are trying it out. And your stuff looks great. I can actually see it. I'm live streaming onto YouTube as well, so it looks pretty good out there.
Oh, thank you.
All right.
So, how much time? It's approximately like 30 minutes for me. What do you think?
Yeah, 30 minutes, 35. Will that work for you? And then as long as people,
sure.
We'll finish in 90 minutes.
Yes.
All right, great. All right, I'm going to go ahead and switch and go ahead and do get my stuff shared again. Hi, everybody. If you're just tuning in, we'll get started in just a couple minutes. We're doing some setup here, and we'll let people come in. Excuse me. All right. All right, you should see my screen again. Now, let me see how many people we've got. All right, we've got 4 attendees. Oh man, that's great. Oh, hey Denise, how's it going? And Vadim, in fact, I'm going to go ahead and allow people to talk, so you can all come and say hi. Oops.
Hi, Robert. Yeah.
Hey Denise, how's it going? Hi Vadim.
Hi, thank you. I would say great even.
All right. So anybody wants to talk, you can unmute yourselves, say hi, where you're from. Welcome to the party.
Hi, it's Barry calling in from London. Hello, everyone.
Oh, awesome. Great.
Hi, guys. It's Andrei Mishinkin from San Francisco. Alexei, do you remember me?
Oh, hello, Andrei, and hello, Denise. It's a big pleasure to meet with you again. I didn't see you for years.
Yeah. This is sort of friends getting together, huh?
But I am following you.
All right. So I think we had about 40 or 45 signups, I think. So we'll give people a couple more minutes to get in, and then we'll see how it's, and then we'll get started. So anybody else want to, oh, here's 2 more. Okay, a lot of talk. All right, I'm just unmuting people as they come in, and you can just say hi, tell where you're from. Looks like we're getting crowds coming in. So I'm coming to you from I'm coming to you from Berkeley. So, and Andrei's is coming to you from Moscow. So we've pretty much got a pretty good time zone coverage here for the speakers tonight or today.
Sorry, Robert, is this session going to be recorded as well? Will it be available on?
Actually, it's being recorded two ways. I'm streaming it onto YouTube, which will probably be kind of a crummy. I don't know if that's going to be a real great recording, but when I kick this off, I will actually start I'll start recording it in Zoom, and then we'll publish that afterwards. So hopefully somebody, if you don't see it being, I think you guys can see that it's being recorded. If somebody notices that it's not, just yell at me, and that'll remind me to set it. Last time I kind of forgot to do it until 20 minutes in.
Perfect. Thank you.
So just a little, let's start doing some intros here. I've basically, we don't have a huge crowd today, so I've basically unmuted everybody, and you're welcome to chip in and ask questions and say where you're from. So I'm in California. I run the SF Bay Area ClickHouse Meetup. So we have pretty regular meetings about every 2 months or so. And anyway, in my day job, I'm the CEO of Altinity, and I think as a lot of you folks know on the call, we do support and now actually a cloud platform for ClickHouse. So we're pretty big on it. It's a great database. So, and Alexei, you want to just give a quick intro? My friend Alexei Studnev is here. I think a number of you guys already know him, but Alexei, if you want to just introduce yourself.
Yes. Hello, everybody. I am in St. Petersburg, Russia right now, and I work at BitQuery startup, which we founded with Dean, who is also joined, I see. And we are dedicated to data analysis of blockchain. And we will talk today not about blockchain, but about the technology that we use.
Great. I'm going to go ahead and kick off the recording here because I think we've got enough of a crowd we can get started. So, all right, recording is started. We're also live streaming to YouTube. So once again, this is Robert Hodges. I'm one of the leaders of the SF Bay Area ClickHouse Meetup, and we're going to be doing a couple talks today. I'm going to be doing a beginner talk on your first ClickHouse data warehouse, and then Alexei, who's a former colleague coming to us tonight today from Moscow, is going to be talking about ClickHouse and GraphQL. They have a totally cool, did a totally cool project where they glued GraphQL onto ClickHouse, and so you get a look at that. We'll run Alexei's talk afterwards, so if you've never heard of ClickHouse before, you'll at least have a little bit of a sense of what it's like. I'm just a little bit about, so we run this using webinar format because it's a little bit easier to manage. So what I have done is, because we don't have a big crowd today, I've unmuted pretty much everybody I could. So, if you want to say something or ask a question, you can speak up, or you can just type it into, there's a Q&A box here. You can also go and type it in there, and we'll see that. So just a little bit of housekeeping. Our next meetup is going to be on January 20th, and that's going to be a repeat of our popular office hours. What we do is we try once a quarter, excuse me, have an office hours where we have the top people from the ClickHouse community. In this case, it's Alexei Milovidov, who many of you know, Denis Zhuravlev, who's also known as Denny Crane on Telegram, and Alexander Zaitsev, who's CTO here at Altinity. They're all going to be just doing office hours and answering any question you have about ClickHouse. That'll be, we'll kick that off with a talk from Alexei. He's going to do one of his the freshest winter features of ClickHouse, and he'll also talk about probably talk a little bit about the ClickHouse roadmap coming up in 2021. There's just a boatload of really interesting stuff happening. So for example, we've been doing a lot of work on S3. There's a bunch of security features on the way. We have some plans in progress to improve transaction consistency in ClickHouse. Those are just a few of the many things that will be covered in that talk. And if you have questions about using those features, I'd definitely invite you to come. We run it basically until people get tired of asking questions. So with that, I'm going to go ahead and dive in. This first talk is an intro for people who are developers and are coming to ClickHouse for another database. I think a lot of you aren't in that in that position, but I still hope you'll find some things that are interesting about it. And we'll also use this as a recording because we just want to make it easier for devs to get in and be able to use ClickHouse efficiently. By the way, we had a question that popped up from Andre. Will the session be available offline after? Absolutely. So it's streaming to YouTube right now, so that recording will be available. I'm also recording it through Zoom, and we'll post that afterwards. We'll probably break the talks up into pieces, and we'll also post the slides as we generally do when we're not lazy. So, okay, I'm going to get diving into the talk. So your first ClickHouse data warehouse. And let's make it go forward. Alexi, can you just confirm that you can see my screen okay?
Yes.
Okay, great, thank you. All right, this is just a little bit of bio and a brief bit of marketing about Altinity. I'll promise it'll be short. So I've been working on databases since 1983. It's the main thing I've been doing in my career. I've been actually programming since I was a kid, which is now over 48 years since I started. So as I say, mostly on databases. I've worked with about 20 different databases, of which ClickHouse is the latest and currently my favorite. I've done a couple of detours into things like virtualization and security. We had a company that we sold to VMware in 2014, so I spent 4 years working for them on those topics. And then I do a lot of work with Kubernetes. We're as a company, and also our users are pretty big on running data warehouse in Kubernetes, so that's a topic we come to pretty often. As far as Altinity, we're the enterprise provider for ClickHouse. So if you're a big enterprise and you're building, or a little enterprise for that matter, and you're building analytic apps, we help you do it successfully. So we do services. We have a cloud platform. We'll touch on that in this talk. And most importantly for the community, we sponsor community events like this. All of us have long careers in open source databases. Most of us worked at some point on MySQL or around MySQL. And as a company, we're big committers to ClickHouse as well as the ecosystem project. So we're, after Yandex, the #2 committers. So that's us, and that explains why we're doing this talk and why we love, just telling people about ClickHouse. So let me introduce ClickHouse. I don't know if there's anybody on the talk who hasn't heard about ClickHouse, but if you have, if this is your first time, this part of the talk is for you. So ClickHouse is an open source data warehouse, and data warehouses are designed to answer open-ended questions about business data. And by open-ended, I mean that you will ask a question, for example, like, how many sales do I have by region, by product? That's a pretty standard one. But basically, any combination of sort of properties that you might have about sales, you can combine them in a query and then ask to see aggregates, for example, like numbers of sales, amounts of sale, average sale, the place where you had the least sales, the products that had the most sales, things like that. And these often involve data sets that are extremely large. They have a lot of properties. So in other words, a wide number of columns, or wide range of columns, and the data sets can be very, very long. So when we're dealing with machine generated data, as for example, web logs from clickstreams, the number of records that you have to deal easily runs into trillions, even for trivial applications. So that's the kind of problem that data warehouses are designed to solve. And ClickHouse is really the first data warehouse that's uses SQL and really can compete with proprietary products like Snowflake, like Redshift, and like others. You can think of it in some ways as kind of like the MySQL of data warehouses. And so like it has a lot of similarities with MySQL. So for example, it has a single binary. It understands SQL. It's pretty portable. Excuse me. It runs on everything from bare metal to clouds, anywhere that Linux does, basically. Where it departs from MySQL, and we'll talk a little bit about this later in the talk, is that it stores data in columns instead of rows. We'll talk about that and what that means, but basically the effect is you can think of every column being it being stored as an array. And whenever you're reading data or writing data, you're basically just doing sequential, always doing sequential I/O. It is also very good at parallelizing query, and this happens at a couple levels. So within a single host, which is what we'll be talking about today in this talk, ClickHouse is very good at breaking up these columns into pieces and farming them out to all your available CPUs or cores, as the case may be. And we also use SIMD instructions whenever we can. So a single instruction, multiple data. The idea is that these are vector instructions that allow you to do operations on multiple pieces of data simultaneously. And this is only possible when you're dealing with arrays. ClickHouse also parallelizes very well. So in the sense that we can spread data across many nodes. There are people that run clusters with hundreds of nodes, and you can actually have queries that span dozens or even 100 nodes. And ClickHouse will happily go out, sort of query each of the nodes and then federate the results back and hand you an answer. It scales, obviously, if you're talking about that kind of parallelization to petabyte data sets are very common. And it's open source Apache 2.0. The big thing that people really notice about it is that it's super fast. I have a demo, which I'm not going to do today, but it's a video on our site where I run a query that is, I first used generated in-memory numbers, and then I go read from storage. And the thing I always say is, well, what do you think is faster? It turns out that ClickHouse can actually read faster off storage than data generated in memory, at least if you choose the query properly. So it's really quick. So that's ClickHouse. It's so what I'm going to do now is I'm just going to talk. Let's imagine that you're coming to ClickHouse and you've never seen it before. The first question is how to install it. And this is pretty easy. And I think most people on this call are tech folks, so you're not going to, this is not going to be a big deal. But your first choice is you can just use standard Linux installation mechanisms. Personally, for me, when I'm developing on ClickHouse, I prefer to run it on a VM. So I'll just spin one up in Amazon or on one of my local machines in my closet. And then depending on what I'm running, I'm typically an Ubuntu kind of guy, so I will install it from Debian packages. And that's the commands we're showing here. But there are also community builds for RPMs and tarballs. And so if you run the commands that are shown here, you're basically just going to get the latest so-called stable build, which means it's kind of a bleeding edge dev build. It's past the basic test, but it's probably not something you want to run in production, but it's stable enough that you can start development. And you can do the same thing with RPMs or tarballs. So that's a simple way to get started, is just spin up a VM, or you're maybe running Linux on your laptop, just install it. It doesn't take a lot of resources to run. Another way that's really popular, though, to run ClickHouse, and this is particularly in build pipelines or for people who are running like on a Mac where there isn't really there are builds for Mac, but they're not super stable. You can run it in Docker. And so this shows the Docker command to set it up. We're using a minus, if you're familiar with Docker, we're using a minus volume setting here, and that's so that our data will persist. You know how Docker images are, they have a habit of disappearing. This will ensure that if we blow the container away, we don't lose our data, which is a good thing for Docker. It also allows us to upgrade it. So, and we do, we just go ahead and reroute the ports, which are 8123 for HTTP traffic and 9000 for what's called TCP protocol traffic, and you're up and running. And if you have a good network connection, both this and the previous one, you can basically have ClickHouse up and running in about 60 seconds. So the third way that you can get hold of ClickHouse, and this is a recent thing that's really just happened this year, is there's actually now emerging cloud platforms for ClickHouse. The first one to get out of the gate was from Yandex. They run it in yandex.cloud. So if you're in Europe, and are happy, content with running in Yandex data centers, you can check out the Yandex managed service for ClickHouse. We have at Altinity run what we call Altinity.cloud, and that runs in Amazon. It'll eventually run in other places, but for now that's runs there. So that's a final option, that if you want to spin up ClickHouse and really try it out, this is another thing to do. this is particularly interesting if you want to try out the capabilities of the data warehouse and kind of understand, like different configurations of storage, amounts of storage, numbers of nodes, replication, all these sort of fancy things that are, sharding, things that are used to build large systems. They're actually, cloud systems are very nice because they allow you to try that stuff out really quickly. So that's 3 ways to get hold of ClickHouse that are pretty good, and people use all of them. The final question for getting started is, where's the docs? And it turns out that ClickHouse has a really great, for an open source project, has a really good set of docs. A lot of work on this done primarily by the Yandex team. Go out to clickhouse.tech, and there's a really nice website out there. Ivan Blinkoff, who's one of the main community people, it put a lot of effort into putting this together. It looks great. And so there's documentation, sort of get started type documentation. There's also reference documentation for ClickHouse features. And any of us that use ClickHouse, we spend a lot of time out there. I basically usually have about 4 or 5 tabs of this open at any given time. So that's the first part of, when you're first encountering ClickHouse, this will get you started. So the next thing is, how do you get started on application development? So you've got ClickHouse up, it's running. And so the first thing you want to do, or what we recommend, is go check. If you've never seen ClickHouse before and you don't have a system that you can just start working with, go run the ClickHouse tutorial. So this is on the website. The URL is shown here. And what that's going to do is show you how to get hold of a pet data set. I think it's the airline data set. I didn't scroll down far enough. I load it from a different location. But basically, it will walk you through how to load an interesting data set. And for ClickHouse, interesting means, like 150, 200 million rows of data. And it will show you different, like how queries are structured, how tables are structured, introduce you some basic features of ClickHouse. If you go through that tutorial, you have a pretty good sense of what ClickHouse can do. So that's a really great way to just get started. And what's cool about ClickHouse is that this is something that you can do even if you really don't have much database experience. The tutorial walks you through. So if it's your first time using, for example, a data warehouse, you can you can be productive fairly quickly, and get started. So the next thing you do after you've done that is go load your own data. So the really interesting thing is to see queries running on your own data sets. And so, sorry about that. Must be another customer calling. So let me just go through some hints for how to get started. So the first thing is just to start out by designing a table. And one of the things about ClickHouse that's, if you're just beginning, is ClickHouse is super fast for reasons that we'll dig into shortly. So what you can do when you're setting up a table is, what I recommend is, don't stress about the table very much. So, don't stress about getting the data types right. Don't stress about, making sure that you have the right primary keys and things like that. A lot of the stuff that you have to deal with, for example, in MySQL or Postgres, where you really have to think about third normal form, don't worry about that. Just stick all your data into a big fat table, get the data types roughly right. We actually know people who just start out by putting everything in as strings, and then over time they just evolve them into the right data type. So here's a simple table. The things you do want to do are, you want to use what's called a merge tree table. That's the kind of the workhorse table. I'll show you how it works in a second. The second thing is, you'll want to partition your data. So partitioning breaks the data up into pieces, and this is really important for making data warehouses run quickly. It breaks the table up into pieces that can be processed in parallel. And generally speaking, if you're dealing with any large data set, there tends to be some time component in it. So a pretty standard way to partition is to partition by month or day. Just pick one. You're aiming for something that gets you maybe a few hundred partitions. So, if you have a year's worth of data, doing it by day is great. If you have 10 years worth of data, doing it by month works pretty well. That would give you, in both cases, about 360 or so partitions. you have to provide an ordering, and I'll show you how this works in a second. You just pick something reasonable. In this case, it's a table of sensors, and so I'm just ordering them by the sensor ID and time. And then finally, compression is really important in data warehouses, but you don't need to worry about it when you're starting out. We'll talk about how to optimize that shortly. All right. Oh, have a question about this partitioning. Yeah, so let's see, it's Svetoslav. Let me find you and you can.
Hi.
Hey, yeah, go ahead. I'm going to flip to the next table because it'll probably illustrate what you're going to ask about.
Okay, in the query, in the create table query you were showing, it was partitioned by year and month. So,
yes.
For example, my project has a lot of data, which is statistical data for clicks, and it's usually grouped by day, month, or year. And we plan to introduce an hourly breakup, a grouping. So what would be the best partitioning by? Year plus month would be enough, or we have to
actually, depending, unless your data set is huge, I would just start by partitioning by month. So what'll happen is the fact that you're grouping at the hour level, that's no problem. That's taken care of in the queries. And we'll see some examples of how that's dealt with shortly. So yeah, just go for month.
Yeah, it's an affiliate network actually, so the data would get really, really large, I assume, because it also includes revenue share offers where the same click can buy multiple times. So
okay, no problem.
Year and month, that would be enough, I guess.
Yeah, that's fine. That's a good start. What is actually more important is, and so here's what the table looks like underneath. And I need to make sure that I don't go too long on this talk so I don't freeze Alexia out. But underneath, the parts are organized, and if you go in and look at the files, you're going to see two general types of things. You're going to see what's called an index, primary.idx, which is a sparse index. And by default, whatever you order by is going to be used to construct this index. And so in the previous example, I was using...
It's more about the grouping. It's more about the grouping by...
Yes. Yeah, so what this is doing is if there's a natural... Well, actually, what's interesting about this ordering is one of the most interesting things. So one of the things that's really important is to get good compression on the columns. You want to organize your ordering in such a way that the columns don't vary as much from value to value. So for example, if you have just imagine that you have sessions on a website with users. So the properties of any click in that session tend to be roughly the same across that session. So it's kind of nice to have an ordering that includes session, because what that will do is it will mean that there will be potentially long stretches in your columns where the ordered values, as the columns are sorted by that order by, very, very little. And so your compression is going to be fantastic.
Okay.
So
our problem actually is that we have a click ID where each value in the table will be totally unique.
Okay. Yeah. So, well, what you want to look at, this is something where I actually think it's important, again, as you're starting out, don't stress about it, because it's really easy to figure out whether it's working or not. And then what you will want to do is allow for the fact that you may need to reload your data a couple times as you're, in development, as you discover different ways to order it, and so that it gets the best performance.
Yeah. Okay. So we'll add it on the development server and test the best performance. Okay. Thank you very much.
You got it. Okay. So merge tree then, it has the index. You have this sparse index, like when you use the index, that order by, it can be used essentially as a primary key. It will find rows, but the other important thing is that what it'll be looking for is it'll go out and it'll just use this sparse index to find the blocks containing data. But these blocks are pretty big, so they will by default hold about 8,000 rows, the values for 8,000 rows in each block. And what that means is that like if you do a read and you look for a single row, you'll effectively, over the columns that are in your select, you'll be reading 8,000 rows. So it's a kind of interesting property of ClickHouse. And we'll look at that a little bit in a second. So next thing you want to do once you got a table is load your data. So two popular formats for loading that we use a lot are CSV and ClickHouse. These are called input formats in ClickHouse, and ClickHouse supports a bunch of them. But two real popular ones are CSV, either with or without the names at the top of the columns, and what's called JSON each row, where each line contains like a little JSON blob, as you see in this example. And you can load these pretty easily. If you have small data sets, the simplest way to do it is just to pipe them through clickhouse-client, which is your standard client for talking to ClickHouse. Super useful tool. So this is how you connect to ClickHouse. And what I'm doing is, for example, just catting the readings.csv. That CSV values in the query that I'm going to run is insert into meetup.readings, and then I tell the format that the pipe stuff is coming in, and that's it. We use this for loading, in some cases, hundreds of millions of rows, or billions of rows even. Same with JSON. So this is a quick way to, and pretty easy to do from the command line. There's another interesting way that you can read data, and that's through what are called table functions. So a table function, and this is an example of what's called a file table function. It basically reads your data. It looks inside the ClickHouse, it looks like a table, but it's really reading from a file. So in this particular case, it's reading from a file called readings.json. There's the format is JSON each row. You have to give it a clue what your data types actually are. So you'll need to, this is an example of how you do it. This particular one, table function, requires the files to be in a known location where ClickHouse can find them, and it's by default in this place called varlib ClickHouse user files. So those commands up above are just, kind of getting the data out there where it can be read. And that's a little cumbersome. So actually, if you're really reading a lot of data, one of the best ways now is to get it out of S3. And this is pretty new in sort of ClickHouse 20.8 and beyond. ClickHouse 20.8 is a sort of a mid-year version of ClickHouse that's now stable, or fully stable for enterprise use. So you can read from S3 in using a command like the following. The cool thing about S3 as well as the files is they will take wildcards. And what that means is, like, if you had, like, say 100 of these files, you could actually read them, and there's a setting that allows you to parallelize them. But this is a really good way of loading a lot of data fast. So if you're coming off Snowflake, what you could do is dump it to S3, in whatever format Snowflake dumps it in, and then read it back out like this. So the final thing is, like, sort of as you're, planning your attack on, or your siege on ClickHouse, is now you've got your data loaded, or some fraction of it, just go crazy with your own queries. And what I recommend doing at this point is just go read the start with the docs for Select. Select is the most well-developed part of the ClickHouse SQL vocabulary, and it is incredibly powerful. It doesn't have window functions. That's one difference if you've used other data warehouses, but it is incredibly, it's incredibly feature rich. It has these things. So for example, it does group bys really efficiently and easily. It has basic support for common table expressions. It has arrays, which I just wrote a bunch of articles, blog articles about it. So incredibly powerful feature. These are all things that you can do. Oh, by the way, there's a question from Barry. About that S3? Does it support local S3 deployments like Minio? The answer is yes, and in fact, it supports it better than S3, because when we initially started, we were using Minio, the free version in the build pipeline. So yes, it supports that quite well. So you should be able to use that. All right, so back to Select. So that's, at this point, you're on your own. You're sort of, you're now surfing your data. You're up on the board. You're, riding the waves, and just try stuff out. And so one question you'll have is, of course, if you're developing apps, what about client libraries? Well, there's a bunch of them. available. So I've got 5 of the most popular ones. Interestingly enough, and there's more of them listed on clickhouse.tech. For PHP and JavaScript, there's a bunch of little libraries, but actually what a lot of people did, and what we did, for example, we do a lot of PHP. We actually didn't even use a driver. ClickHouse has an HTTP interface that allows you to submit the queries just using HTTP and then get the get the results back as a payload in various formats. So we just rolled our own. It took. I was talking to Andre a couple of days ago, and he said it took him about 2 hours. So you can write very, very simple code, and that's particularly important coming from like Node.js or PHP, where they've already got good support for REST API calls. You can just do that. So for my own part, I normally use Python or ODBC if I'm working with it, but we do a lot of work with Golang. That driver is also very stable. And then of course, C++ is super stable. Java is okay. That actually is probably the least well-maintained of all of the ones that are shown here. So for the final part, I'd just like to talk about a little self-defense. It's possible that you're coming to this and you've worked with other databases, so like MySQL, and in which case your brain is probably somewhat polluted, and it's important to have a little bit of a notion about what's going on under the covers, and particularly to understand the difference between a row store and a column store, which is also a data warehouse. So so MySQL is a good example of a row store, and the way that it works is that, let's say that we have, this is sort of a cartoon of a table, and you've got columns A, I, and K that you want to select from, but the data in MySQL are all stored in rows. So what that means is that if you do a query where you're just looking for those 3 columns, MySQL is basically, without a lot of extra direction, is just going to allocate a single thread, and it's going to go and read each of these columns, or excuse me, each of these rows one by one, pull out the A, I, and K columns, and throw everything else away. What that means is if you have like 100 gigs of data, which is, for analytics, kind of a small table, you're going to read 100 gigs just to answer, just because you're doing a table scan. And so as a result, when you're using MySQL, in fact, you always add indexes. You tend to do a bunch of things that reduce the number of rows that you actually have to look at. The problem is that analytical queries often require scans. So this is why databases like MySQL don't do analytic queries very well. They do other kinds of queries, and we'll talk about that. What happens with ClickHouse is that because the data are stored in columns, if you refer to 3 columns, that's all you read. There's a couple files for each one by default, and ClickHouse will allocate multiple threads to read them, typically based on the number of cores that are available. So it zips right through them. And so we're reading compressed columns, we're reading them in parallel. And so the fact that we're only reading the columns already means that there's essentially no penalty for having very wide tables. So having tables that are highly denormalized and have a bunch of extra data, you just don't pay for them in the query because you don't look at them. So this is an example of an airline data set that actually is the one that figures in the tutorial. And if I have a query that reads 3 columns, I'm actually only going to read about 3% of the data. The table has 109 columns. And so I will only read those 3 columns and leave everything else. So already I've cut out about 97% of the data. What's interesting though is on top of that, I don't read the uncompressed size of the data, which would be normally the case with MySQL. I'm going to read the compressed size. So these blue bars here actually show in this particular table how much data there really is in the columns based on how well they compress. So the ones that don't have a blue bar were data, ones that didn't have any data, so there was nothing even to read. So that's the second thing is that you want to understand about ClickHouse, is that beyond the fact it's reading by columns, is that it's really important that the compression has a magical effect on your performance. as you're doing these big queries. And there's 3 ways that you can get data to compress. First is to choose a good data type. So one that's not too big. So, like if you can fit it into 2 bytes, great, use 2 bytes. The second thing you can do is put codecs on it. So a codec is a transformation that changes the data. And then the final thing is compression. So codecs know about data, compression doesn't. Compression just sees bits. So here's an example. There's a data type called low cardinality, and that's a dictionary encoded string. So what that means is instead of storing the string, you actually store an integer that represents that string, and you put the string in a table somewhere. And this is great for strings where there's maybe 10,000 values. So for example, worldwide airport names is a good example. There's no codec applied to this, and then let's say we do LZ4 compression. That's the default out of the box compression. It's quick, it doesn't require much tuning, and it's not very expensive to decompress. Here's another example. We're storing something as an unsigned 32-bit int. We're going to put a double delta codec on it. So instead of storing the ints, we're going to store the slope of the ints. So imagine temperatures, for example, or sensor IDs, which are sorted in such a way that they're sequentially increasing. What that means is we may store a very, very small amount of data, and then we're going to apply ZSDD compression to it. So this is an optimization that when you actually start to get close to deployment, you may want to go in and change the tables. And ClickHouse gives you a huge amount of control over this. So in this particular example, I'm using ZSDD1 compression. There's different levels, and I'm using different codecs. So T64 for decimal. That one is reasonable for decimal. Double delta, as I just mentioned. I'm also doing another trick where the date can actually be computed from the time. And so I use what's called an alias, which makes it computed. And if I want to save space at the cost of some extra computation, that's something else that I can do. All of these reduce the amount of stuff that I'm going to have to read. So, and the effect is phenomenal. So there's a table called system.columns. As you dig into compression, you want to get very familiar with it because it shows you the column values or the columns for all of your tables and tells you what the compression levels are. So for example, that sensor ID, when we apply, and time columns, when we apply the codecs, we get down to basically close to 1,000-fold reduction in the size of the data. It's really impressive. Temperature, which is stored as a decimal, that doesn't compress so well. So hey, nobody's perfect. But this means that this is one of the big reasons why ClickHouse can do these big scans so fast, because the amount of data it's actually reading is very, very small. So this is, like thinking about compression and getting it to work is something you really want to do. And then there's the final thing that ClickHouse doesn't use indexes in the same way that databases, conventional row databases do. Row databases like MySQL use indexes to find things. And one of the things you get used to in MySQL is the notion of a covering index, where, for example, you're looking for the maximum value of something. Well, you can actually, if you have an index that has the values, you can just read that out of the index. And so you have a lot less stuff to scan. And so people will look to try and do this in ClickHouse. Well, ClickHouse doesn't work that way. There are indexes, but they're used to avoid reading things. Instead, we have what are called materialized views. And materialized views are basically a transformation on a table. So you have like a readings table, which I've been using as an example. I build a materialized view that stores the minimum and maximum temperature for each sensor for each day. And it's kind of like an index. It vastly reduces the amount of data, and it allows me to reduce the size of the query. And as a result, by constructing this materialized view, I can go ahead and do a query that comes back lightning fast because it doesn't have to scan a lot of data. So this one came back in about 1/100th of a second, or 11 milliseconds, which actually for this kind of thing is kind of slow because but the thing that you have to know about this was actually running on an Intel NUC, which is a very, very low power machine, and the data the data set that was coming from had 500 billion rows on the NUC, and the materialized view is able to reduce it down to something where I can get the query result this quickly. So this is a very, very powerful feature. And when you think about indexing things, one of the things you want to look for, think about, like, hey, I would have used an index in MySQL or Postgres. Think about a materialized view to help make it faster. So in general, performance tuning is really different. I think for devs, this is actually advantageous because there's no query optimizer. This means that if you're not a SQL DBA or like an Oracle weenie, you're not expecting, you don't have to understand a lot about the database to understand the magic it's doing, because it's not doing any. What you end up doing is tuning your queries. There's a system log, which is really powerful. You have these system tables, which can tell you things like compression. You just learn to use these and basically make your queries faster. And the performance of ClickHouse queries is really simple. It's basically driven by the IO to do the scan, and then the amount of CPU you can apply to the stuff that you read. So that, so there's a bunch of, and you'll get to learn over time, which parts of it can be parallelized, which parts have to be done in sequence. But this is stuff that anybody can learn. I think the number one tip is to use the ClickHouse query log. It's basically tells you what ClickHouse thinks it's doing and how much data it's reading. So like if something is going slow, you go look at the query log, you figure out, okay, it looks like it's reading a lot of data, and then you try and make it read less data. Or it doesn't have enough threads, okay, give it more threads so that it can get through it faster. So these are just tricks for enabling it. And just generally, the final thing you want to know is where to use ClickHouse and its strengths versus a row store. So row stores like MySQL are tuned to do what's called online transaction processing, or OLTP, which means that, if you're running a website and you have a lot of small lookups, for example, to build pages or to look at the contents of shopping carts or to check whether somebody's logged in, MySQL is really great at that, because often the data you have to look at is just one row and it's all in one place. So you can nip in, do that. Similarly, you can update it quickly because you don't use a lot of resources for these queries. You can have a lot of them. And they also have great consistency models. So in Postgres, for example, you can create a table, add data to it, create another table, add data to it. You can basically all do that in a single transaction, and it either commits and succeeds, or it rolls back and wipes everything out. These are all things that row stores are really good at. ClickHouse is different. It's designed to answer questions about large data sets. So very long tables, and that's where the scan capability is important. Very wide tables. So the column store, the fact that you store things in columns gives you this advantage that you don't have to, you reduce the amount of data you read. Open-ended questions, things for which you don't have an index in advance. And then lots of aggregates. I haven't really focused on aggregates too much in this talk, but ClickHouse has a huge library of aggregates that it can perform. And so any kind of computation where you're sort of grouping things and ordering them, ClickHouse does really efficiently. And the performance for these types of use cases is sometimes as much as 1,000-fold faster than MySQL. And MySQL is, don't get me wrong, MySQL is very quick for the things that it's designed to do, but for these analytical queries, ClickHouse can easily be 1,000 times faster. So that's it. I hope I haven't gone too long. Be happy to answer a couple questions while Alexia is getting set up. These are some more information. There's just a bunch of stuff now out here. There's a worldwide community generating information. The ClickHouse.tech docs are great. There's a ClickHouse YouTube channel. Altinity has a blog where we, sort of do long form articles. We also do a lot of webinars on this stuff. And then finally, the ClickHouse source code. If you can't figure out how something works, one of the best ways is to pull the source code and go look at the tests. They have the best examples of how to use different SQL features, some of which are kind of obscure. If you see it in a test, it works. So, and you'll get get a clue about what it does. So that's it. Thank you very much. I hope this talk was helpful. We want to do more stuff to make it easy for people to learn ClickHouse and sort of jump in and use the value. So I'm going to go ahead and turn this over, stop my share and turn this over to Alexei. But while Alexei's setting up, we can take a couple questions if there are any, or we can proceed to Alexei. So I'm going to kill my share. Alexei, if you want to just go ahead and do a share your stuff.
Yeah, sure. I'm starting.
Oh, here's a great question. Thank you, Rafi. What would be the recommended way to ingest big data as part of a data pipeline? One word: Kafka. So yeah, that's thank you so much for mentioning that. I probably should have put that into the talk because we're trying to give people basics. Absolutely recommend Kafka. About half the people doing big data are using Kafka. You can either write your own app, sort of to read from the queue and poke it over into, push it over into ClickHouse, or there's something called a Kafka table engine inside ClickHouse, which can read from Kafka topics, and basically it kind of makes a Kafka topic look like a table, and so it will read from it, and what you do is you connect a materialized view to it, and periodically it'll just snag the data that's on the topic and then put it in a ClickHouse table. So that's a great question. Thank you so much for asking that. Okay, let's see. What is? Here's a question from Denise. What is usually the bound, I/O or CPU? Generally speaking, I/O. I/O is going to be the #1 thing that you're going to want to control for. And here's the reason that that I/O is, that you want to focus on I/O. You can add CPUs to, so for example, when I was playing around with this talk, I was just using my nuke to try a couple things out. It has like 4 threads. Now I could go to like get a decent processor and maybe it would have 40 hardware threads, but that is only going to increase things 10 times. If I go and change the, the compression, I could reduce the amount of data that I'm scanning by 100 times. So that being able to read this stuff really fast, and storage is kind of slow to begin with. So being able to reduce the amount of storage that you have to touch as you're reading things is really important. Okay, I'm going to quit talking. I will hang around, and if there are more questions, we can answer them later. But hey, Alexei, I'm going to turn this over to you. My former colleague, Alexei Studenev, from BigQuery, is going to take it away and talk about GraphQL for analytics. So go for it, Alexei.
Yeah, thank you, Robert. It was wonderful to listen again about how ClickHouse is great. So, and actually, our company started with ClickHouse because Alexander Zaitsev recommended me to use the ClickHouse for the task of indexing the blockchain. It was at the end of 2017, I believe, when ClickHouse wasn't so major as now. But I think this decision defined like 50% of the success of our company, because we were ahead of competitors who used like Elastic or Postgres or other solutions. And I would thank, of course, thanks to Alexander for this recommendation. We founded the company called BigQuery, and it's dedicated to the blockchain analytics. But today, we'll focus just on one particular technology that we use. We use GraphQL for analytics on top of the ClickHouse, and I will explain why we're doing that, why we did this choice, how we manage this. We will have the short demo. Then also I will show you some internals of the functionality, and talk about some future plans, how we see it in the future. So using GraphQL for analytics is not very like mainstream, right? So probably didn't see it before. And we don't see any examples. And that's why actually I'm talking about this one right now, because it's not standard solution. It's kind of questionable, but we have a rather positive experience till now, and I want to share that. So what we're doing, we reading the data as events from different blockchain networks, and it's rather standard ETL process which doing this. We don't use yet Kafka, but actually we're planning to migrate this process to Kafka pretty soon. We store all the data in ClickHouse in many tables. And this many tables is one of the issue that we have. So why we have many tables? First reason is natural, because blockchains are different. We now have approximately 40 different blockchains like Ethereum, Bitcoin. Some of them similar, but most of them are rather different. And we cannot just physically place everything in one table. It doesn't make any sense. The second reason is what Robert mentioned, is materialized views and aggregates. So of course you need to use it, because we have a runtime performance which is critical for us, and from one table we immediately get 10 tables or even more, and so it multiplies. So I don't know the exact number of tables we're running now, seriously, but it's above 200 or maybe 300. I cannot count them. They grown pretty fast, and it's just a big zoo of tables. But when we come to our clients, we want to present ourselves not as a 300 tables, but as the API, which is easy to use, and everyone actually can query some information from blockchain. Actually, our business is based on the fact that the blockchain is rather hard to query for analytics. It's so designed. So it may be good designed for query for one particular transaction. It's like MySQL, but it's pretty hard to like answer the question, how many Bitcoins is traveling every day? What is most active addresses on the blockchain? What is suspicious activities, like abnormal transactions? What smart contracts are most popular? So many questions that we can answer with using ClickHouse aggregates. But it's very hard to answer if you don't index the data. And we have free public tier. We have also the subscription tier, like SaaS model. And also sometimes we install the dedicated systems. But in all cases, we have the single API that's used by applications. It's front-end applications, back-end applications, different kind, mobile even. So they use the same API. So this is our like business. This is very high-level view. So from left to right, maybe we skip it now. So what exact problems we have when talking about API? First problem that I said, that we have too many instances of things. So we have blockchains, schemes, tables, aggregates. For example, if you just want to query for some easy thing, you need to know all this stuff. You need to know where the table. So first of all, you need to know what scheme to query. You need to find this particular cluster. You create this SQL query to it. You need to know which dictionary to use, how data is encoded. You need to select which particular aggregate or which particular materialized view to use. So for each particular query, you may select one or other depending on performance optimizations. So you need to know too much things if you just want to query. And in our case, it's just unacceptable to show this to clients. We we even very tentatively give them the schema if they ask only. We try not to give them the schema of the database because it's hardly manageable in our SaaS model. But we want to have one API. We want to have the single point when a client can easily use HTTP or some REST API and to easily query the data. And actually, we started with very easy queries. So people asked us particular data, and we created, every time we created new endpoint. And it's very fast. We met with the scalability problems of just our development. Because it multiplies on the number of blockchains, first of all. So for one blockchain, you implement this method. For another blockchain, you need again implement this method, and so on. So, and it multiplies on the complexity on the physical clusters. So you need to find a particular table and cluster. So you can imagine that this very fast, it's just unmanageable situation when you want to implement like every feature manually as an API. But also the clients need different fields and different joins. For example, one client needs join with market data for Bitcoin. He needs to know in each transaction, he needs to know what was the price for Bitcoin. Another client wants like additional fields which were not added. And this also, like if you add all these requests in your API, the API will grow. So you will fastly like come up with all the fields that all clients require. So completely unmanageable. So that's all these problems actually I just listed them to show that our clients actually do not want to make them think, but all this hassle lies on our side. And this was a problem from our side. And which solutions to this problem we considered? First of all, we can give them SQL. As I said, this meets with a scalability problem on managing all these tables, schemas, and supporting the SQL. If we allow our clients to run SQL directly in the database, we of course could consider making some kind of layer of views, common views. But even that will not solve all the problems because it's very hard to create the view which optimizes the query. Because in one case it must read from one table, in another case it should read from another table. I know that say Vertica have something similar to this feature, but ClickHouse, as far as I know, it doesn't have. And this is very easy optimization. We have much more sophisticated optimizations like unions and joins sometimes. So it's very hard to present as views. View is not a programming like declarative kind of language. It's just SQL. Another thing which we consider is just continue to use HTTP JSON, but I already explained that it's easy to use by client, but very inflexible and very hard to manage. It's somewhere on the right side of this diagram. XMLA MDX. It's XML for analytics, and MDX, it's something Microsoft. And actually, in my previous company, we used this technology over Vertica. And it could be used with ClickHouse as well. But we, as I remember, we met with, it's not easy technology in terms of learning curve. So it requires some reading some materials, how to make queries. It has some concepts. So you must be professional in all AP programming to use that. That's not acceptable for us. Our clients are not typically like programmers of a lab system. They're just, most of them are just use our system with a bunch of other systems. We are just one of the row. We cannot force them learn that. And the last one is GraphQL. So we don't know where to place it here in the diagram because we actually don't know the examples of good usage of GraphQL over analytics. But it has some important features on the next slide that tentatively give us some hints that it may be good. It may be good. It was, yes?
Alexei, can I just insert a quick question? Is there an engine for XMLA to ClickHouse? Because I know you were looking at it. There was a question from the crowd.
I am not aware of that. I actually maybe I didn't hear about that.
Okay,
I didn't
thanks.
hear. But probably because it was even before. It was 2000 maybe 16. I don't remember the year. Or the previous company, we created the XMLA bridge to Vertica, and it works. It should work above any JDBC driver, so it can be connected to ClickHouse as well, I think.
Okay, great, thank you.
Mm-hmm. So what is GraphQL? GraphQL, it is generally the name of GraphQL is very confusing. It was, as I understand, it's invented by Facebook to query like friends. Say if they show the page on the Facebook, they want to query not just your name and picture, but also your friends, maybe some posts. And when you change the interface, you need to change the specification of data you need to query. But because Facebook need to optimize, then they need to create some query language which defines which particular data you need to show on the page. That's how I understand GraphQL was created. So it's not about graph. It's more like how to query data for browser. It's more about that. It's JSON query language. So if you need to query JSON, so probably GraphQL is the best way to do that. It has schema. Schema defines what you can query, and schema is very good. It creates self-documentation of your API, first of all, so you can rely on that as a documentation. Also, it's validated on every query, so the query all validated. It's very useful. Then it allows to build editors of queries that I will show you today in demo. That just make it easier to build the queries, even if you don't know how to build that. It just forwards you in the right way. So schema is also JSON apparently, but schema defines what you can query. Easy. And by the way, it's more strict than SQL schema. It's more strict. It defines not just data types. It defines the structure. It defines data constraints. A lot of things. So schema is very specific about what you can query. And the idea is that you can query only what you need. So one application may query only one attribute from table, one column. Say another will query 10 columns, and this will be the same API. And this is the power. This is main point of all this list. Why we selected? Because this is exactly our case. We want to query. In some cases, we want to query all the network. In other case, we just want to query one transaction. And we don't want to build API endpoints for network and another API endpoint for transaction. That's not what we want to build, because we come with this. We already passed this stage with REST that it's not a manageable situation. Also, GraphQL supports updates. They call it modifications, and also it's subscription model they have, but we don't use it now. Maybe in the future. And yes, it's not used yet for LAP, but we're going to fix that. So this is GraphQL, and let's go to some demo how it actually works. So first of all, this is a GraphQL. It's just off-the-shelf editor of GraphQL. It understands the schema, so it loads the schema from the endpoint. It understands the endpoint. This is our endpoint. And it shows it in the docs here. So you see the top level element, query, and here the elements that you can go to, say, Bitcoin network. It shows what options you have here. You can go here to the, sorry, it's not here. Yes. So this is fields that you can query, say blocks, coin path, inputs, so on. It's our specific schema, but it's the schema that I talk to you about. And this left is editor. So it has very nice feature of it context, understand the context. So the first I type query, and then I see the selection of types that I can use, and we consider this as you can consider this as a data set, your data set. So for example, I can query like Bitcoin, our data set. The next step will be inside the Bitcoin, you can query the cube. It's not exactly the table, because I will show you further that there can be many tables under each of these cubes. So for example, I select blocks, and then I select what I want to query. For example, I want to query the count of blocks. And I got the first like valid query. I can execute it, and I get the result. So it's the first like valid query. And as you see, what's very wonderful around that the structure of response is exactly the structure of query. So you literally define the structure that you want to get on the outside. So for, if you want to query, say you want to include here the year, you can add here the dimension year, and it will group it by year. So now you see it, the count by the year, and so on. So you can add here as many like dimensions. For example, block version. This is the version of protocol of Bitcoin, and you get here the block version together with year. And in all that cases, I get the result very close to the original query. So I literally define what I want to get, and I don't care about from which table it reads, from which like cluster, how I create the SQL. So we do it for on the back end. Also, what is nice, that I can add here another data set immediately here and compare, say, the same counts per year, say, for another chain, Ethereum. And it will return the, so it will return the Ethereum. So this query actually consists of two, and it reads from different tables, even from physically different clusters. But for what's important for our users, it doesn't matter. So they just use it as if it's like single entity. So how this can be actually used? So say we can create all these queries for your cubes. We directly can use it in the browser. That one option. So we have some demo explorer. For example, we have the data sets for different blockchains. Here we have the COVID data. And if you say go to the map, so this is example how I build this map. This map shows how many people with confirmed COVID exist today on different countries. So it has the simple query here, which we execute, which we create just in JavaScript in browser. We submit it to the GraphQL API. We can execute it here. It has the dimension, country, name, latitude, and metrics confirmed, death, recovered. And what's nice about that you can actually build an analytical system without any server. So yes, because this query is created in browser, it's executed in browser, it only submit the GraphQL to server and get back the results. But the programming of the query happens in the browser. That's very important. So you don't need any servers to compose your query, to manage your query. You can build completely serverless analytical platform based on that. Because typical approach, like what we see in MicroStrategy and on others, they have the servers that actually create their visualized like data for you. And this is very different from, this is much more lightweight from user perspective. And of course, you can get this query placed in your JavaScript application. It will work the same way as I'm showing you, no difference. Just place it on JS Fiddle, it will play the same. Like I can even do it very fast. I can just copy it from here, run JS Fiddle. The only thing for JS Fiddle, I have to separate here script from HTML. That's what I do manually, but everything else should be fine. So yes, I run it and I get it here. So, and you can combine, here you have the same query. This is the query to the data warehouse. So you can edit it here, like changing, like since you can change the date here, for example, there, or something else. So you can build serverless applications. Let's dig deeper. I will briefly explain what is this query is about, because typical OLAP set looks like this. It's minimum. So you need to have dimensions, filters, metrics. You need to have cubes and data sets. Actually, I've taken this approximately from XMLA model, but I know that OLAP systems work pretty similar to each other. In our case, when we have like, this is like more complex query. By the way, it queries, let me explain what it queries, because it's very practical thing. It queries the prices of trades on blockchain for different coins based on time interval for 5 days. And it calculates minimum price, maximum price, quote price, open price, close price. So it creates the so-called a candlestick diagram, which when you see. So this query completely built all the data for this candlestick diagram, just one query. And it consists from all these entities that I've shown. So first of all, it's the entity is dataset name, Ethereum in this case. The cube, it's DEX trades. It has dimensions, time interval, currencies. It has metrics. So what is the difference between dimensions and metrics? Actually, there is very small difference. And interesting that XMLA considers metrics as just one dimension, just one additional dimension of special type. And I kind of agree with that. But what's important to see that typically metrics are numeric and they can edit, calculated maximum, minimums. Typically, they behave somehow differently from dimensions. And all these entities are in this query, and also filters. Filters allow to limit the scope of query if you need it. So dimension, how I understand it in GraphQL. First of all, it is of course defined, all dimensions defined in schema. So you have a drop-down list of them when you create a schema. But it also have so-called attributes. So attribute means that sometimes you need just symbols of currencies, sometimes you need addresses, and sometimes you need different aggregations of dimensions. So attributes, you can consider attributes as sub-dimensions. And the level can be not just one as here, but it can be more than one. So you can have dimension, then you may have attribute, and you have attribute of this attribute, and so on. So it can be as deep as you need it. And you can query on every like level of this structure. Also, we call so-called function here. Actually, GraphQL names it attributes. When you look at GraphQL specification, these brackets are called attributes. But we put special meaning in that. We consider that in this count, the day has function count equal to 5. It means that it's like a specification of what you need to query. Another example is format of, say, date. You need to have dimension formatted with formatted date. Another example is in which currency you need to have the result. So we have a lot of usage of these functions in different way. We call them functions, while I said in GraphQL there's no such thing. And we found it's quite useful because you cannot define everything. You still need to leave some kind of programming inside the query. So this is our programming model, what I'm showing you. And this is our like understanding how GraphQL can be mapped on analytics. Any questions? Do we calculate metrics on our backend in advance or use aggregated tables for that? Both. It depends on optimization. I will talk about like in 5 minutes about that in more details, but the answer is both. Depends on the query. Yes, and another question, when the query is converted, I'm assuming you are doing aggregation. Do you aggregate only over the listed dimensions? I would say that ClickHouse doing aggregation for us, not we, because we compose the, ultimately we of course compose the SQL statement for ClickHouse. And there is definitely group by there, and ClickHouse makes an aggregation in this case.
Hi, Louis here. Thank you
Yes.
for your answer. So, okay, I was just curious on this because when I did an implementation with group by and a dynamic dimension, we had some caching issues. So some clients will cache the GraphQL query based on what's provided. So we had to pass the dimension that were in the group by as a function. So I don't know if you had a similar issue or something like this, but
Oh yes. By the way, I didn't mention that. Really, some GraphQL clients, some of them have caching function, but we turn it off.
Understood.
Mm-hmm. And also the question you asked, is the dashboard displaying GraphQL or a custom page, or is it Grafana? I would say JavaScript. So it's a custom page that you create using JavaScript, where you place just calls to GraphQL with this endpoint, and you can create this JavaScript in any framework that you need. It's not Grafana, of course.
Thank you.
Mm-hmm. The next one is metric. What we understand as metric. As I said, we consider it some numeric, but also in many cases, it's not just enough to define that you have like count. You need to specify it in more detail. So we again use these attributes as functions. So we have metric, we have the alias for metric, sometimes we need it. And also we have the function which defines which particular like formula we need to apply when we calculate in this example. Another example below is minimum of block get quote price. It means that we want to have the quote price for minimum of all block in the aggregation. So here we get open price. And again, we using the attributes as functions. So literally, we consider this line of code as give me minimum and apply function of with argument block and function get with argument quote price. Internally, it works like this. But in GraphQL queries, it even can be read as like sentence. Minimum block get quote price. It's as natural language. It's kind of fun. And what is under the hood here? As I said, there is no, at least we didn't find any implementation of this. So we built our own, which is not very hard. So a GraphQL library, it is in every programming language available. We selected Ruby language just for historical reason. We have more than half system built on Ruby and Ruby on Rails. And we added like special library for so-called active cube, because Ruby on Rails has active records. So we created the library called active cube, and active cube converts queries from GraphQL to queries to ClickHouse, to SQL essentially. But it cannot do that just automatically because it doesn't understand how to do that, and we need to explain. And the explanation is cube definition. And let me show how it looks like very briefly. The cube definition is the code essentially. So for example, this is cubes. Let's open some cube here. So the cube defines which tables it can use. So in this case, it can use 3 tables because one table, say, optimized by one criteria of order and another by another one. And if we don't do that, then we will not get performance that we need. This active cube, when it doing the conversion to SQL, it of course knows all the attributes of the tables, and it makes a query depending on like which field need to use as potential index. Then it has dimensions, so it defines here the dimensions which we can use, metrics that you can use, and the filters, and that's it. So basically, this is a cube. The schema is generated from this. Also, the SQL is generated from this. So this active cube looks at this definition, and it understands like what it can use for which particular like query. It selects dimensions. It selects metrics. It composes SQL for the tables that defined here. So in brief, it works like this. Yes, it's in Ruby, and it's not. It's open source. ActiveCube is open source gem, and it's evolving. So I would not say that it's very stable because we constantly add in some new features there. But we use it in the close to production system right now, and that's works pretty good. So let me overview what we get from all this. So we think we built rather easy to use tool set, first of all, because how we detect that? Because we have, say, Telegram channel where people playing with the system, they posting these GraphQL queries back and forth like every day, and we don't have any documentation, by the way, nothing. Like we have some blog posts which describe some examples, but we don't have any like book of documentation where described how it's used. So people using it without reading it, and it's a good sign. So of course we need to write documentation. I know that, but it's development goes like faster than the pen, as always. The other thing is important. There are multiple off-the-shelf tools for GraphQL editing, schema composition. I mentioned here Observable HQ and Postman as a startups who make some kind of environments for using this kind of APIs to embed it into their. I can briefly show you, by the way, the Observable HQ. By the way, it's a great tool. If you never tried it, you should, of course, try it. We built a notebook there just to demonstrate that we can embed the query here. This is the query, and it builds these graphs. When I load a page, it actually queries the data warehouse, returns data here, like, and this is example of dashboard. And by the way, it's example of this serverless architecture of analytical system. So you can consider this Observable HQ as a very simple analytical system that we converted into this dashboard, right? API-ready solution for SaaS client. We convert our clients very soon to this GraphQL API. They're pretty happy with that already. So we make deprecated REST HTTP to GraphQL. And we have projects, of course, and plans. First of all, we need the help from community because unlike REST API, people can build own queries. That's very important. They can build own queries, share that. We already try to incentivize that, not by money, but by attraction and attention to what they do in. So build a community is our plan. Also, technically, we have a lot of enhancement that we need to do. We plan to have the so-called flexi graph, because the schema right now is very, I would say, rigid, but we need to have a flexible schema where anybody can define what he can potentially query. And that needs some, this is a layer above the current system. Like the function of a schema. We have a big demand on that. For example, one use case for that is ability to query a different data set and combine them into one. That's a very evident example, which is pretty hard to do right now. Like if you try to find the ready-to-use solution, it's not as easy. Another thing, we need complexity estimator. That's, by the way, very important feature for every project of analytics. So you need to estimate the complexity of the query before you execute that. Resource management, measurement. So we need to measure how many resources we spend. So estimator estimates this, but we also need to measure. And we also go into enhance our ADE and dashboard builder, which I briefly shown you, to make the query building as easy as possible. So thank you. If you have any question, please post it or speak up. This is our website. This is our email. And if anybody interested to contact them, we'll be very happy in helping you maybe answer questions or using this technology. Thanks.
Hey, Alexei, that was an awesome talk. Thank you so much. So I don't see any pending questions right now, but we can hang around for a bit to answer questions on this or any other topic regarding ClickHouse. I think in politeness to Alexei, if we have further questions on GraphQL, I'd like to take those first so that Alexei can go to bed at some point, assuming you do that. Yeah. So I think one of the questions that was sort of on the chat was, is there an open source library to resolve the GraphQL queries to ClickHouse SQL queries? And there just isn't. I mean, you guys have built this active cube. That's sort of is that the correct answer?
Yeah. This is GitHub BigQuery. And this active cube is somewhere here.
Yeah.
Here is it. There are several libraries, Active Cube and Active Cube GraphQL. So they have some documentation. Maybe, I didn't create it like a big technology. So probably it needed my help if somebody will actually use it. But I will be happy to help. So yes, it has some like examples and.
Cool. I had a question. It was interesting that you had the integration with Observable. Does Observable also go directly to ClickHouse? I'm just curious if given that you've worked with it.
Yes,
or does
it can. Oh, yes, yeah. It can. Yeah, it can through HTTP. You can create an observable. You can create. Yeah, of course. Yes. The example that I showed use GraphQL, but you can use HTTP with SQL.
Did you have, just given that you're familiar with Observable, did you feel there was, what did you feel was a trade-off of using GraphQL versus going straight in with an HTTP request?
Oh, the main, so from observable point of view, there is actually almost no difference. Yes, but the difference appears by the fact that you open your database to the world, which we kind of not will, and due to many reasons which I described.
Yeah.
I know that many people also will not wish to do that. But still they need to expose some kind of interface to open world. So the question, what will be that interface?
Right. Great. Any other questions from the crowd? Once again, great talk from Alexei and from the BigQuery team. Okay, well, hey, I think if there aren't further questions, I think we might call it a day here. I'd like to thank Alexei again, once again for doing this great talk. This is the first time that we've ever had anything on GraphQL, and I just really appreciate you sharing what you've learned at BigQuery.
Yeah, thank you for inviting me. It was a pleasure to talk in your company.
Yeah. Great. Well, then what I'm going to say is we'll see you. I hope you all have enjoyed this meetup. We'll be doing another one on the 20th of January. Definitely sign up. Come bring your questions to try and stump Milividov, Zhuravlev, and Zaitsev. They will be our combined team of experts. So we'll see you in about a month. And happy holidays, everybody. Have a good one.
Thank you.